I'm very happy I'm invited to this conference. I'm working as an associate professor in Nile University, Egypt. I'm the head of the materials lab. And one of my students was with project trying to find the replacement for styrofoam, since styrofoam has a lot of negative effects on the environment. So we found out that one of the important waste materials that could be transferred into a useful product is the waste of the sugar cane, which is called bagasse. So it had some properties that were not really good. So we tried to improve and enhance the properties using some of the applications that we tried in the lab. So I'll walk you through a simple outline, which is first talking about disadvantages of styrofoam, then why bagasse is a replacement, and then the manufacturing process of bagasse, and then the tests that we did to confirm that this would be a good replacement, and finally some results and conclusion. Can we move to the other slide, please? So basically, styrofoam or polystyrene is used for food packaging, and it's a synthetic plastic, and of course, it's a petroleum-based plastic, and it is not biodegradable. And since we're concerned with the environment, so we were looking for a biodegradable alternative that has the same properties of styrofoam. Next, please. So we found out that agriculture waste was one of the options for us to be a replacement for styrofoam. We tried several agriculture waste. However, bagasse, which is the natural fiber from sugarcane waste, was a strong, very cheap, and it is easy to dispose. Also, it is available since Egypt. We did a feasibility study at the beginning, and we found out that Egypt has a lot of amount of manufacturing companies that have leftovers for sugarcane. They are in Upper Egypt. So we started to think about the manufacturing process of the bagasse, and we found out steps. Can we please keep the other slide? The one before, please. Yeah, the one before. Yeah. So I'll just talk about the beauty. So at the beginning, there should be some of the pulping process that should be done to the bagasse, which is the waste of the sugarcane, as I mentioned. And then after the pulping process, it's a chemical process that should be done, and then shaping at a certain temperature and pressure, and then it can be used as a package. So when we started our process, we found out that the pulping process is very expensive. So we approached the companies in Upper Egypt the pulping process, so it would be easier for us. And then we purchased the raw material after the pulping. However, the raw material was in the form of a liquid. Can we move to the other slide, please? We wanted to prepare a sheet from the liquid that we received from the companies in Upper Egypt, and then we should dry it. So we manufactured a lab scale roller that could be easily able to prepare the sheet. At the beginning, the samples were received around 90% water and 10% bagasse, and it had a thickness of 8 millimeters. In order for the forming process to occur easily, we had to do the rolling to so that the thickness of the sheet would reach 1 millimeter, which is suitable for the forming process. So we tried several trials to make sure that the thickness of the sheet is 1 millimeter. And then we tried several rolling processes until we optimized all the conditions. However, there was one advantage during our work, which is that the bagasse sheet, they are they need some water resistant or water repellent material because they have a problem of hydrophilicity. So we added that we tried several raw materials that could be added as water repellent, and they are, of course, biodegradable too. So one of the water repellents that we used was AKC, which is a natural component, and it really improved the water resistance, as I will show you now in the results. Can we move to the next slide? So the next slide is the thermoforming process, which is the second one. It is basically a process where needed to be at industrial scale because we don't have the machine. So we sent our sample to our industrial partner who was really able to help, and then we used his forming machine. And under heating, after this sheet that we tried, we used the forming to produce our final product. Can we move to the next slide? So we started from the sheet, and then we ended up with, after thermoforming, these final products that you can see in front of you. So these plates are basically biodegradable, and they are used for food packaging, and they are approved from the FDA, since all the materials that are used are user-friendly, environmentally friendly, and it's a very cheap product compared to the other synthetic styrofoam current ones. Let's shift to the next slide, please. So in order to be sure that all these plates could be a replacement for styrofoam, so we basically did some characterization techniques, which is concerned with the biodegradability and the mechanical strength of the plates, and of course the oil and water resistance. Since after we added our so we started with yeah, next one, please. So the biodegradation test was done according to the ASTM standards for biodegradable materials, and the biodegradable material in water was completely dissolved after 20 days, and it was totally degraded in 60 days in the soil. Can we please move? So as we can see here, that after 21 days, it was completely dissolved in water, which is actually what we were looking for, because we needed it to be a one single time use, and after that you could dispose it in water, so it will dissolve and biodegrade. And in soil, we stopped at 21 days, of course, after to make both tests the same, and then the weight of the plate really decreased from 0.34 to 0.21 in the soil. And this was a very good biodegradation result. For the oil and water test, we simply added this AKT, as I mentioned at the beginning, and then we recorded the weight after 30 seconds to evaluate the amount of absorbed liquid at each time. Next, please. The initial weight of the sample was 0.46 grams, and it reached 0.7 after 120 seconds. While for the oil, it was also resistant, so it started with a sample of 0.32 and it reached 0.63. However, when we tried the normal sample without any water repellent, it was double the weight, so we were sure that there was an effect for the oil and water repellent. For the mechanical testing, we have the instrument universal testing machine in our labs, and the test was done according to the specifications of the ASTM standard of the biodegradable plastics. And the result of the mechanical behavior was very promising, since the strength of the sample was about 14 megapascal. And when it was compared to other current tensile strength of similar bagasse products, it gave the same almost tensile strength. So this really encouraged. Yeah, next, please. We were very enthusiastic with the results, and we found out that we could solve the gap and the low properties of the bagasse alone, of the sugar cane bagasse alone. So we could say now that we are able to use the bagasse products for biodegradable disposable plastics industry to replace the styrofoam, since they are low cost and biodegradable in both aqueous and aerobic environments. And the AKG was very successful in water repelling. Thank you so much for this opportunity to explain my work about biodegradation.